today is we're going to look at medication. As I mentioned, this is really applicable, particularly if you're working in a pharmacy or if you're doing nursing. Even if you're not doing nursing, it is still, Bailey, a really good example of how to apply algebra into the real world. Okay, so let's have a look at what we're doing today. So the first type of example is all about converting, okay, a concentration. So let's have a look at this example so we get an understanding. It says the concentration of a medicine is given in 100 milligrams, okay, per 50 mils. What is the dosage rate? What does the word rate mean?
Right.
How much?
Yeah, so they're wanting the rate to be in grams per millilitres. Grams per milliliter. Okay, so a rate is just something like kilometres per hour, metres per second. It's something like you do something per a time frame, okay, or something per a quantity of liquid, etc., etc. So let's understand what they're wanting. They want us to convert 100 milligrams per 50 millilitres, and they want you to change that into grams per milliliter. Okay, so grams per milliliter. What is wrong with this? Compare these two.
One's milligrams and one is grams.
Yeah, one is milligram and one is grams. Okay, so before we can do that, what we need to do before we do that, what we're going to do is change it into 100 over 50. And we're going to leave it at milligrams at the moment to millilitres. So I need to work out what 100 divided by 50 is. What's that? Yeah, 2. Well done. All right, 2 milligrams per milliliter. But then you say, no, that's not how they wanted it. They wanted it in grams per litre. So now becomes the conversion. But it makes it a bit hard when you don't know how many grams are in, like how many milligrams are in a gram. So what does 1 gram actually equal in milligrams? Milli means 1,000. So milli... not milli, milli. Yes, it is milli, sorry. Milli means 1,000, okay. Centi, what does centi mean? 100. Okay, so you can do that like a century or whatever. So milli, there's 1,000 milligrams in 1 gram, okay. So we've got two milligrams. So to work out what 1 milligram is, if I divide both sides by 1,000, okay, that is how many grams. So 1 over 1,000 as a decimal is what? 0.001. Okay, is that okay?
Yeah.
All right, so I know that 1 milligram is 0.001, so 2 milligrams would be 2 lots of that. Grams per milliliter. The 2, because, good question, okay, where did the 2 come from? Because 100 divided by 50 gave me the 2. Is that okay? That's a really good question, so that's clarified for you. All right, so I've now done, what's 2? Whoops, go back to my normal pen. What's 2 times 0.001?
0.002.
2 grams per millilitres. Okay, so there's a little bit of prior knowledge that you need to know here is how many milligrams are in a gram. So that information up here, okay, might do it over here. So 1 gram, milli means 1,000, okay. So 1 gram equals 1,000 milligrams. So 1 milligram was 0.001 grams. Another way of looking at it. Get a copy of that one down, and then we'll get on to... All right, we all ready for this one? Is anyone not ready? Okay, so in this question they give you a formula. They say this formula is used to change the dosage given in a tablet form to the equivalent concentration in liquid form. Okay, so this is the liquid. How do I know this is the liquid?
Because it's the liquid.
Yeah, but how do I know? Because of that milliliter, it's a quantity that's measured of a liquid. So that's the liquid. Okay, so this is in the tablet form because it's measured in milligrams or grams. So let's have... So let's have a look. Okay, let's have a look at what this question is asking. So Joseph is prescribed 100 milligrams of a painkiller. Okay, the medication is available, contains 100 milligrams in 5 millilitres. Okay, how much medication should Joseph be given? All right, so this is where people go, I'm a bit confused here because I'm not sure which number goes where. Okay, that's why I want everyone watching. All right, we're being asked to find how much medication should Joseph be given. So what we need to find out is the volume. Okay, and what's volume measured in again? Look at the formula. Millilitres. Okay, so here's your formula up here because that's what we're going to be using. All right, so what is the strength required?
MJ is 100.
100 or is it the 1,000?
Not bad.
1,000. 1,000. How do you know that? Because that's the part that confuses people. It's in the sentence, yeah. So what it's saying in the sentence is that's what is prescribed. So that's what what's required, what's needed. So that's where we work out that number goes on, oh, wrong pen. That number goes on top and it is measured in milligrams, so I don't need to convert it, okay, because it says here it needs to be measured in milligrams. And what is the stock strength? The medication contains that much in 5 mils. Okay, so that's your 5 millilitres and that is your stock strength because that's how it comes. Okay, so then we need to work out what that is. Now, if I didn't have a calculator, what can I do with these 2 zeros? Yeah, so I'm dividing the top and bottom by 100, or you just cancel that out. So that becomes 10, okay, by 5 millilitres. So what's my answer? It's 50 millilitres. See how the L for millilitres is a capital L? It's just how they, when you write millilitres, that's how you should write it. Okay. Right. So, have a look at this here. Bailey? All right. So, what we're looking at now are the Freed's, Young's and Clark's rule. This is a rule which is used to calculate the required dosages for like infants or for children. Because obviously, like you'll see on the back of a Panadol packet, it might say 2 tablets for an adult, but for a child it might be, 1 tablet. For an infant, it might be, like half a tablet. Okay, so obviously because of body size, you have to have different different sort of dosages that you need. And these formulas, they'll give this to you, okay, because we're not expecting you to remember the formula, but we are expecting you to be able to apply the formula. Okay, so let's have a look at what the formulas are. So first of all, what are Freed's, Young's and Clark's rules? So what we look here, the purpose for each of these are the dosage for children. So just write here, dosage for children. Okay, and the age for, what do we call that's for children that are 1 to 2 years. Okay, so each of these rules are a little bit different, and you just need to use the table to determine which rule you're going to use. So the formula here is dosage, and that is equal to the age of infants, of the infant. But when you do that, okay, it needs to be in months. That's really, really important. And you times it by whatever the adult dose is. Okay, and then you divide it by 150. Okay, so just get a copy of that down. Dosage for children that are aged between 1 to 2 years. Okay. What is, if I said to you a child, if we had to use this formula, was 1.5 years old, what would I convert 1.5 years to?
18.
Yeah, so to do that, that'd be 18 months. Okay, that's nice and easy because we know half a year is 6 months. But if I said to you 1.2 years, that might be a little bit challenging. But what would I do to change that to months? I would times it by what? 12. Okay, so that would be 14, okay, 0.4 months. Okay, so that's why you've got to, so just be aware that 1 year is 12 months. All right, we're going to apply these formulas in a moment, but I just wanted to go over what the formulas are. Let's have a look now at Young's rule. So with this rule, instead of it being, so just put dosage for children who are aged between 1 to 12 years. So how is this rule different to the one above? Yeah, the one above only goes to how old? 2 years. This one goes to 12 years. Okay, now this guy come up with this formula. The dosage, and write this in, is equal to the age of child, but this time, the age of the child, you need to insert the years, not the months. Okay, and we times it by the adult dosage. Okay, then we're going to divide that by the age of child, okay, in years, okay, but you need to add 12. So on the bottom, if the kid was 2 years of age, what would I be dividing by?
150.
Age of child in years. If the child was 2 years of age, I'd be dividing by 14 because 2 plus 12 is 14. If the child was 5 years of age, what would I be dividing by? If the child was 5 years of age, I'd be dividing by 17. Okay, so that's the application that's a little bit different. All right, now the last rule, okay, just write dosage for children. This rule is dosage for children, okay, this is in general, so there's no specific age group. Okay, so what this Mr. Clark came up with, this is the formula he came up with. Dosage, okay, is equal to the weight in kilograms, okay, times it by the adult dosage. Once you get that answer, you then divide by 70. Okay, so it depends on the question. So the question may give you the weight of the kid, okay, so you would use that formula. But if they give you the age, you use one of the formulas above. So that's how you go. They'll either tell you which formula to use, or they'll give you the weight and you use that formula. All right, so let's have a look at a question. Has everyone got that?
Yeah.
All right, so let's have a look at a question. All right, Young's rule is used to prescribe medicine for infants. The formula is this one, okay? So let's have a look at that formula. This is Young's rule here. So this is the age of the child, times it by the adult dosage, okay, and then put the years plus 12. So it's the middle formula. So the variable D represents the infant's dosage in milligrams. Okay, so that's what you're going to end up with, and that'll be in milligrams. Okay, and A is the adult dosage in milligrams, and the infant's is in years, which is what we set up here. What is the dosage, okay, for a 3-year-old child, okay, if the adult dosage is 50 milligrams? So we've got a 3-year-old child, okay, so let's have a look. The dosage, and this is for the child, okay, so I'll just put a little C there. Let's write the formula out. Y times A over Y plus 12. Okay, so let's have a think about what Y times A is. Okay, so what is Y? Yeah, so how old? 3. So this becomes 3. Now YA, what is YA? It is Y times A, isn't it? And what does A represent? The adult dosage. Okay, so what is the adult dosage? 50. So this becomes 3 times 50 over 3 plus 12. Does that make sense? Yep, fabo. So you could either, if you wanted to enter that directly into your calculator, you could do this, put brackets in, and then press divided by, or you can just go, well, what's 3 times 50? 150. And what's 3 times 3 plus 12? 15. So what would that be?
30.
10. Okay, but 10 what?
10 milligrams.
Milligrams. Okay, 10 milligrams. So get that down.
Almost go to the 3.
Yeah, we're finished now, so you may go to the toilet. Do you need a key? Was it open, Kobe?
Yeah.
Yeah, cool. All right. Okay, so that, my friends, is exercise.
Isn't there 1 more, 2 more minutes?
Oh, is there? Oh, there is. Okay. Rightio. So get started with exercise 3G. You've got enough knowledge to do that. I will go and record the other 2 questions in your book and upload them onto the Google Classroom. Does anybody need a textbook?